Lesson 6 is solving one and two-step linear equations, and by the end of lesson 6, we'll even get into a few multi-step equations. So starting with 6.1, which is one and two-step equations, up at the top it says linear equations are named after the straight line they create when they're graphed. So if we sketch a little graph, we have an x and y axis, and then a linear equation. Linear just means like a line. So a linear equation would look something like this. And of course, it could go in a different direction, but the main thing is that it is a straight line. Like you could draw it with a ruler. There's no bends or crooks or anything like that. So just kind of keep that word in mind that linear just means a straight line because that's a word that will come up throughout your math career. Hey, before we get started on the actual problems, I just want us to remember the concept of inverse operations, which I know we talked about a little bit during the exponents unit, but inverse operations are operations that undo. So they're operations that undo each other. So a couple of examples of inverse operations would be addition and subtraction. Those would go together and undo each other. Multiplication and division. And then from the last unit, we know squared and square roots. I'm going to write that as like with a little question mark, squared, and then also a square root. Okay, so addition, subtraction undo each other, multiplication and division, exponents and roots undo each other as well. So starting with example 1, the first one-step equation, it's x plus 5 equals 18 right here. And our goal in solving equations is to isolate the variable. So in this case, x. So we have to look at the operation that is being done to x. The operation that's being done to x is there's a 5 being added to it. So to cancel out adding, I would subtract 5. And then if I subtract 5 from the left side of the equal sign, I also have to subtract 5 from the right side of the equal sign to keep the equation balanced. So we always have to do, if we do an operation on the left side, we have to do it on the right side to keep it balanced and try to make sure that there's always like one on each side. So that's kind of why I drew the dotted line. It helps us make sure that, okay, one is on each side, because I have seen the mistake pop up where like somebody subtracts 5 twice on the same side, and that's something that we definitely want to avoid. So I'll bring down the x, and then 5 minus 5, that cancels out, that's 0. And then I have to make sure to bring down my equal sign. And then 18 minus 5 is 13, so I'm left with x equals 13. That's my solution. And remember, when you're solving equations, you can always check. I'm not going to check every one just for like time's sake, but remember to check is you would take your original equation. So for my check, I would do x plus 5 equals 18. I would take the solution that I just got for x and I would put it back into the equation where x goes. So it'd be 13 plus 5 equals 18. And then if I add 13 plus 5, that is 18, which also equals 18. So our check worked, and it just kind of verifies that we got the right answer. Like I said, I'm not going to do it on every problem just because that would make the video a lot longer. But definitely when you're doing like a checkpoint or a test even, it's worth checking each of your answers. Okay, so moving on to example 2 now. So over here, r divided by 4, or r over 4 equals 9. So this time our variables are, that's when we have to isolate. So the operation that's being done to r is it is being divided by 4. So the inverse of division is multiplication. So I would have to multiply both sides by 4. So multiplying by 4 and dividing by 4, those wipe each other out. So I would just be left with r. And then if I multiply 9 times 4, that's 36. So I end up with r equals 36. Okay, moving down to two-step equations. So example 3. So 2x minus 4 equals 12. Most of the time when you're solving a two-step equation, you want to undo addition or subtraction first, and then multiplication and division second. So what that means is I'm trying to get x by itself. There's two things that are being done to x. There is a 2 that is being multiplied by it, and there's a 4 that is being subtracted from it. So most of the time, you want to get rid of that minus 4 first. And the reason is, if I try to get rid of that 2 that's being multiplied by it, I would have to take the entire equation, divide it by 2, which isn't that big of a deal in this case because everything is divisible by 2, but that is not always the case. So sometimes if you choose that step first, you would end up with some ugly fractions. So I would just avoid it altogether. So we're going to undo the minus 4 first. So I'm going to undo minus 4 by adding 4, and then I also have to add it to the right side of the equal sign, so plus 4 over here, and then I'll bring down my 2x, negative 4 plus 4, those wipe each other out. I need to bring down my equal sign, and then I can add the 12 plus 4 to get 16. And then now the operation that's being done to x is there's a 2 that's being multiplied by it, so to undo multiplying by 2, I would divide both sides by 2. Same thing, divide the right side by 2 as well. And then 2 divided by 2 is just 1. So it would end up being a 1x, but we don't need to write the 1 in front. That's just kind of what we're going for. And then 16 divided by 2 is 8. So we end up with x equals 8. And then same idea, if you needed to check your answer, you could just put the 8 back in for x and then see if both sides of the equation equal each other, just like we did up here. And then example 4. So 2/3 times parentheses v plus 7 equals 8. So in this case, we can't get rid of the addition or subtraction first. So there's a few things being done. There's this 2/3 being multiplied. There's that plus 7 that's being added to it. However, because of the parentheses, I definitely cannot subtract 7 first because it's not just 7, it's actually 2/3 times 7, so I can't subtract. Think the parentheses like little jail cells. I have to leave everything inside of it until I can find a way to eliminate this 2/3. So one thing you may be thinking possibly is to distribute. So like distribute 2/3 times v and 2/3 times 7. And technically you could do that and get the right answer, but I don't think that's the easiest way to approach the problem because then you're going to be giving yourself like more fractions to deal with. So I think we just want to cancel out that 2/3. And normally like this 2/3 is being multiplied by the parentheses. So usually if something's being multiplied, we divide by that number because multiplication and division are inverse operations of each other. But instead of dividing by fractions, we usually multiply by their reciprocal. So specifically, when you're dealing with dividing by a fraction, instead of dividing by a fraction, you would multiply by its reciprocal. So the reciprocal is like a fraction flipped upside down. So instead of 2/3, it would be 3/2 or 3/2. And then if we multiply that on the left side, we also have to multiply it on the right side. So when I multiply, I'm gonna go ahead and zoom in so it's a little easier to see. When I multiply 2/3 by 3/2, I can multiply straight across and then reduce, or I can cross cancel. So the 3 and the 3, if I divide both by 3, it would become 1 and 1. And then the 2 and the 2, if I divide both by 2, they would become 1 and 1. So essentially everything has canceled out. And that's actually why we choose to multiply by the reciprocal, because any fraction times its reciprocal is always 1. So it's 1. We don't even have to write it. We can just write v plus 7. And then, yeah, there's parentheses there, but if this is just a 1 out in front, that doesn't actually change anything. So now I can actually drop the parentheses also, and it frees up the v plus 7. So anytime you have a fraction, you multiply by its reciprocal, it cancels itself out, and it'll free up what you have inside the parentheses. And then over here on like the right side of the equal sign, I still have that 8 times 3/2. So if you want, you can think of the 8 as 8/1. And then we can do some cross canceling again. So like the 8 and the 2, if I divide both by 2, the 2 would become a 1 and the 8 would become a 4. And then I can multiply 4 times 3 to get 12. And then in the denominator, 1 times 1 is just 1. So I don't need to write the 1 in the denominator. And then now my focus is just getting v by itself. So I would just need to cancel out that plus 7 by subtracting 7 from both sides. and then I would bring down my v, and then 12 minus 7 is 5. So I end up with v equals 5. Okay, moving down to 6.2, which is linear equations from context. And when you see context, it's kind of like a keyword for word problems. So we're going to take these word problems and we're going to write equations out of them. Okay, so take a second, write down the problems to make sure your notes are kind of good and you can reflect back to them. So 6.2 example 1. The cost to rent a video game from Play Today is a rental fee of $5 plus $2 for each day that the game is rented. How much would it cost to rent a game for 4 days? So word problems are not meant to be read once. So if you read a word problem one time, you're like, I don't know, read it several more times, underline important information, and then kind of try to digest it a little bit more than just that first time through. So reading it a second time, it says that, sorry, my headphones, I'm sorry if you guys can hear it. So it says that there's a rental fee of $5 plus $2 for each day the game is rented. And then the second part is how much is the game going to cost, or how much is it going to cost to rent a game for 4 days? We don't really need to worry about that yet. That's kind of like the final answer we're looking for, so I'm going to leave that alone for now. So before we get into this problem specifically, every single word, like kind of linear equation, has what's called an independent variable and a dependent variable. And usually we use X for independent and D for dependent. So with this problem, we want to kind of recognize, okay, what is our two variables? Like, what do they represent? So I'm going to say X is equal to, and then X is going to be our independent variable. So leave a little note next to X that says independent. And then I'm going to set up a Y equals as well, kind of while I'm here. And Y is going to be our dependent variable. And then these basically mean what they would kind of mean in normal context. Like independent is kind of like doesn't rely on anything. Dependent means that it relies on X. So usually dependent is kind of like our final answer that we're looking for. So in this case, it's probably like the total cost. So how much it's going to cost in general to rent the game. And then you have to ask yourself, okay, what does the total cost depend on? That's going to be our independent variable. So I'm actually going to start with dependent. So Y is going to be the total rental fee or total rental cost. And then ask yourself, what does the cost depend on? Like, what variables are there that impact the overall cost? It says that there's a rental fee of $5 plus $2 per day. So maybe like how many days that we rent it for, that's our variable that kind of impacts our final cost. So we'll say X is the number of days rented. So X is the number of days rented, and then Y is our total cost. So now we need to write our equation, and X and Y are going to be in our equation. And then that 5 and that 2 that are the rental fee and like the $2 per day, those are going to end up in there as well. So we want our equation to give us the total cost. So we're going to start with Y equals, and then we need to write Y in terms of X. So that means that we need to figure out a way to write an equation that puts together the rental fee of $5 plus $2 per day, knowing that we're going to use X for the number of days that we rent. So I'm going to use a little bit kind of backwards for a second. So if we're renting a game, we automatically pay $5. And then plus we pay $2 each day. So like if I rent for 3 days, I would do 2 times 3, $2 per day. So, or if I rent for 4 days, I would have to do 2 times 4 days. So what I'm getting at is I have to take that $2 per day and multiply by that by the number of days that I rent the game. So this equation is perfectly fine. I just want to note that usually when we write equations like this, we put the x part first. So I'm just going to get us in the habit of reordering it that way. So y equals 2x plus 5. So now we have an equation that represents this situation, and now we can answer the question, how much would it cost to rent a game for 4 days? Which 4 days, and x represented the number of days that we rented for, so that means that we're going to take 4 and put it in for x into the equation that we just wrote. So our equation is y equals 2x plus 5. X represents the number of days, so we want to take that 4, put it in for x into our equation, and then that'll tell us our total cost. So it'll be y equals 2 times 4 plus 5, and then remember order of operations, you would multiply before adding, so we would do 2 times 4, which is 8, plus 5, and then we'd get y equals 13, which y was the total cost, so I'm going to say $13 is the total cost. And then before we move on, kind of like a shortcut for writing linear equations is they're always going to be in this form. Sometimes you won't have like a number right here, but in general they'll be in that form. And the number that's being multiplied by x it's called the rate of change. So if you've graphed before, you know, like if you've heard the word slope, it's the same thing. So we'll call it rate of change. And that's just like how much is it changing by like per unit essentially. So like for us, it was $2 per day. It was going up by $2 per day. That was our rate of change. And then that 5, where that $5 is, that's our initial value. So like there was that initial fee of $5. So it was just that kind of one-time charge. And then the 2 is how much it's getting increased by each day. That's our rate of change. Okay, so moving on to example 2, Marcella opened a bank account with $100 her grandmother gave her as a gift. Each week, she deposits $12 into the account. How long will it take Marcella to have $196 in her account? So let's go through, let's find some important information. It says that she opened a bank account with the $100 her grandmother gave her, and then each week she deposits $12 into the account. So we first have to identify what our variables are going to be. We can use example 1 kind of as a basis. So x is still going to be our independent, y will be our dependent. So considering the fact that like example 1, x was our number of days rented, what's the x in this equation? It's like kind of what is, I guess, going to impact how much we're able to save overall. And it says that each week she deposits $12, so x must be the number of weeks she saves. And then for y, like the equation or the problem itself is asking how long it's going to take for us to have a certain amount in our account. So what we're trying to find is an equation that's going to give us the total amount of money that she has saved. So for y, it'll be the total amount of money saved. And then just kind of going back to the independent versus dependent things, that'll kind of pop up throughout the course, and I want us to be able to recognize between the two. So the amount that she saves, that's our dependent variable y. The number of weeks that she saves for, that's our independent variable. So how much she is able to save, like how much money in total she ends up with, that depends. It's the dependent variable that depends on how long she saves for, which is our independent variable x. Okay, so writing the equation now, the equation should represent how much she has in total. So think about how her grandmother gives her $100 one time. So she has $100. And then after she puts that $100 into her account, she deposits $12 per week. So she deposits another 12 per week though. So every single week she deposits $12. So we'll have to do 12 times the number of weeks that she saves for. So 12x. And then same thing, we're just gonna get in the habit of writing the x part first because that's how we'll see them throughout the course. So it'll be y equals 12x plus 100. And then remember we talked about in the last example how the number that was multiplied by x, that's the rate that it is changing by. So it's increasing by $12 per week because she's putting in a new $12 each week. And then that number where the 100 is, that's kind of like our initial value. So she starts off that account with $100. So that's our equation, y equals 12x plus 100. And then now we have the ability to figure out how long it'll take for her to have 196 in her account. So we have to decide where that 196 goes, and you have to look at the variables to figure that out. So x is the number of weeks. If I put 196 in for x, that's saying I am saving for 196 weeks, which that is not the case. So that means I have to look at y, which is the total amount saved. So it's asking how long will it take to have 196 in her account. So that 196 is going to be y. It has to go in for y. So we'll rewrite our equation, y equals 12x plus 100. And then that 196 is going to go in for y because that's the variable that represents amount saved. So it'll be 196 equals 12x plus 100. And then my goal now is to solve for x, is to solve for the number of weeks. So I want to get that x by itself. So I would have to first undo addition and subtraction. So I'd subtract over the 100. And then 196 minus 100 is 96. And then I bring down the equal sign and the 12x. Still trying to get x by itself. So I'm going to divide both sides by the 12 because that's being multiplied by x. And then 96 divided by 12 is 8. So it'd be x equals 8 weeks. Because that x, remember, x represented how many weeks she was saving for. So x equals 8 weeks. Okay, and then moving down to 6.3. So last couple of problems. I know this is the longer one, I'm sorry. So 6.3 is multi-step linear equations. So Leanne runs at a rate of X miles per hour starting off right here, and Tenny runs 1 mile per hour faster than Leanne at 0.75 hours into their run. The sum of their distances is 8.75 miles. Write an equation that models this situation. And then use the equation to find the rate at which Leanne runs. So we're going to use our variables to represent the rate that they run by. So I'm going to say, it even kind of identifies it for us. So I'm going to read through this one more time. But Leanne runs at a rate of X miles per hour. So they're kind of identifying our variable for us. So we can even start there. So we can say X is equal to Leanne's rate. And then it says that Tenny runs 1 mile per hour faster than Leanne. So we don't need to use a different variable for Leanne because we can kind of describe, or sorry, for Tenny, because we can describe Tenny in terms of Leanne's rate. So because it says that she runs 1 mile per hour faster, we can just say that Tenny's rate is X plus 1. So X plus 1 is going to be Tenny's rate. And then now we can kind of create an equation. So at 0.75 hours into their run, the sum of their distance is 0.75 miles. So before we set up the equation though, usually, it even kind of says it in the problem, it says 1 mile per hour. And then our rate has to kind of be in that terms of mile per hour. And they don't give us an exact hour, they give us 0.75. So we're going to have to take that into consideration when we set up our equation. So when you write rate, it's typically miles per hour. So we'll just have to consider that ratio once we set up our equation. So it says, reading through the question one more time, I'm going to go to the bottom here. It says the sum of their distance run is 8.75 miles. So sum means add. So we're going to have to take their two rates and add them together. So for our equation, x plus 1. So this is like Leanne plus Tenny. And if that's their rates, that's equal to, we're going to write a ratio that includes their rates that are given to us in the problem in terms of miles per hour. So they went 18.75 miles in 0.75 hours. So they didn't go like a full hour. They ran it in 0.75 hours. So we'll have to put that down here for where hours would go. So we're just taking like the miles that are given to us in the original problem, the time that's given to us in the original problem, and organizing it as a rate miles per hour. So 18.75 miles over 0.75 hours. And then now we have an equation that we can solve though. So I'm gonna kind of erase this. It's maybe not like the prettiest equation, but it's solvable now. So if I have this in parentheses, but there's no number in front of the parentheses, like nothing right here, then the parentheses don't technically make a difference. I'm just gonna go ahead and erase them rather than writing a whole new line for the problem without them there. And then now I can combine like terms. So I have x and x, so those are like terms because they have the same variable to the same power. So this will be 2x, and then I'm going to bring down my plus 1. And then I'm going to go ahead and divide 18.75 divided by 7.75 because like fractions are just division. So if I do 18.75 divided by 0.75, that's 25. So now I have 2x plus 1 equals 25, and I have an equation that I can kind of start to isolate my variable in. So I am trying to get that x by itself. I'm going to undo addition or subtraction first. So I'm going to subtract the 1 over, and then I'll bring down my 2x, and then 25 minus 1 is 24, and then still trying to get x by itself. So now there's a 2 that's being multiplied by it. So divided by 2, divided by 2, to cancel out, multiply by 2, and then that leaves me with x equals 24 divided by 2, which is 12. So we end up with x equals 12, which if we go back to our original setup, x was Leanne's rate. So we can say Leanne runs 12 miles per hour, and you can shorten that as mph, as miles per hour. And then for Tenny, her rate was x plus 1. So we just need to take 12 and add 1 to it. So Tenny would run 13 miles per hour. So Tenny runs 13 miles per hour. And then for example 2, down here, find the values of 3 consecutive numbers that have a sum of 30. So kind of same idea here, where you don't have to create like 3 different variables or anything like that. We can write each one in terms of like our original. So consecutive numbers mean like they're all in a row. So like 1, 2, and 3 would be consecutive, or like 9, 10, 11 would be, I don't want to put that, I think that was accidentally the answer. We'll see though, I don't know for sure. Let's say 7, 8, 9, those are all consecutive. Just 3 numbers in a row basically. So when I'm defining my variable, I just need to start with the first number. So I'll say x is my first number. And then I don't need to say like y is my second number. I can just say x plus 1 would give me my second number. Because if I'm going from like 1 to 2, I just need to add 1. Or if I'm going from 7 to 8, I'm just adding 1. And that's always the case for like 2 consecutive numbers. And then for my third consecutive, or my third in the like streak, I guess, I would have to add 2. So it'd be x plus 2 would be my third number. Like if I'm going from 1 to 3, I would be adding 2. Or 7 to 9, I would be adding 2. And that'll always be the case for like the third in the streak. Okay, so now it says the sum of 3 consecutive numbers is 30. So if I take my first number, which is x, so x, and then my second number, which is going to be x plus 1, so plus x plus 1 for my second number, and then plus my third number, x plus 2, so plus x plus 2. If I add those 3 consecutive numbers together, I get 30. So now I have some like terms that I can combine. I have a bunch of x's, so I have 1x right here, 1x right here, and 1x right here. So when I add those x's together, I have to think of them as like 1x, 1x, and 1x, and I would add the coefficients, the number in front, to 1. So 1 plus 1 plus 1 would be 3x. And then I can also add my constants. Those are the numbers that don't have a variable. So it'd be 1 plus 2. So 1 plus 2 is 3. Equals, bring down my equals, bring down my 30. And then now I have a two-step equation that I can solve. So my goal is to get x by itself. So there's a 3 that's being multiplied by it and a 3 that's being added to it. So I'm going to subtract over 3 first to cancel out that plus 3. I'm going to bring down my 3x. 3 minus 3 cancels out. 30 minus 3 is 27. Now I have a 3 that's being multiplied by x, so to cancel that out, I will divide both sides by 3. 3 divided by 3 cancels itself out. And then I have x equals 27 divided by 3, which is 9. So I end up with x equals 9, but remember, that's not the like final answer because it says find the values of 3 consecutive numbers, and x was just the first one. So x is the first of the 3. So the 3 consecutive numbers would have to be 9, 10, and 11. And you can always check it. Like if you add those 3 up, you should get 30 because 9 plus 10 is 19 and then plus 11 is 30.